Unit 6, Linear Equations and Graphing. In this unit, you will learn to model and solve problems using linear equations, solve equations using models, pictures, and symbols, and graph and analyze two variable linear relations. Topic 6.1, Solving Equations Using Models. We can use a balance scales model like this one to solve an equation. What is the value of x? X is represented by this symbol here. Okay, this is the value that we want to determine. And we have three circles over here. So on the left-hand side of our balance scales model, we have x plus 3. Now, on the right-hand side of this balance scales model, we have 7 circles. So x plus 3 is equal to 7. Now, if this were an actual balance scale, we would need to keep things balanced in order to determine what the x is equal to. And you may recall that the first step in solving an equation with a variable is to isolate the variable term itself. In other words, we want to get the letter x alone so that we can determine what it means or what it stands for. So what we'd want to do is remove these 3 circles here. We'd want to take them off the balance scale on that side. And we'd want to do the same thing on this side. We'd want to remove 3 on this side as well. So if we didn't, the balance scale would be tilted this way. We would remove 3 on this side, and the balance scale would be unequal, unbalanced. So if we removed these 3, and we removed 3 on this side, we're left with 4 circles. So we could say that x is equal to 4. We can also use algebra tiles to model the solution to an equation. So let's take the following equation, for example. X plus 5 is equal to 5. We model that using algebra tiles. This long rectangular tile modeling the x, the 5 yellows representing positive 5 on this side, the line representing the equal sign, and then 5 more yellow representing the positive 5 on the right-hand side of the equal sign. Now, remember, in order to determine what x is equal to, it's most helpful to have it alone, to isolate it. So that's step number 1. We want to isolate the variable. In order to do that, we want to remove these 5 yellow tiles. And in order to model that using variable tiles, you would add 5 red tiles that represent negative 5. Those 5 negatives would cancel out the 5 yellows, the 5 positives. They would make 5 zero pairs, which together have a value of 0. And you do the same to the other side. Remember, your balance scales model is a great way to visualize that. What you do to one side, you've got to do to the other. Otherwise, those scales are tipped and no longer balanced. So once you do that, all of these would be deleted. They would cancel each other out. All of these would cancel each other out. In other words, there would be no value on the right-hand side. And where there's no value, the answer would be 0. So in this case, x plus 5 is equal to 5. X would be 0. We can also just double check that very quickly. Take 0, plug it in the original equation. 0 plus 5 is equal to 5. If that's a true statement, then we're right. And if it's not, then we've made a mistake, and we can go back and check. Let's try a couple more examples and solve them using models. We'll start with 2x plus 2 is equal to 22. We could use a balance scales model to represent this problem. Start by just sketching a balance scale. On one side, we're going to have 2 x's. So I'm just going to draw 2 squares. Each of them is going to be labeled x to represent the 2 x's. And I'm going to also put the value of 2 over there. It's 2x plus 2. So I've got 2 x's and 2, or plus 2 on that side. And on this side, we've got positive 22. Now, the first thing you want to do when trying to determine a variable is to isolate the variable term. In this case, we have 2 x's. We want to get them alone so that we can determine what one of them is. So we can start by removing this 2 here from this side. We'll remove it. And when we remove it, what you'll find is that because this side would be lighter, the balance scale will be tipped this way. So we want to make sure we remember to do the same thing on the other side. So we'll have to remove 2 from this side to keep things balanced. So we've got 20 remaining over here instead of the original 22. All right, so now that balance scale is balanced again. Now we have 2 x's over here. We can then match each one of those to its proportion, or its portion, of the remaining value over here. Another way to look at that is to take this remaining value and to distribute it among the 2 x's. And if you consider that, the number 20 would have to be divided into 2 separate parts. So each of those x's would have a value of 10. So our x in this case would equal 10. Let's solve the second example using algebra tiles. 8 is equal to -6 minus 2x. Now for my model here, if it's black, it's going to be positive, and if it's red, it's going to be negative. Okay? So, I'm going to start by sketching 8 positive tiles on the left-hand side. I'm going to make a line here to represent the equal sign. I'm going to now have 6 negative tiles, and I'm going to have 2 negative variable tiles, because in this case I've got -2x. So there are my -2x tiles. Now, because these tiles are negative, and we're really looking for what a positive x is, or what just x is, in other words, one way to solve the problem is to add positive variable tiles. So what we want to do is get rid of these negative variable tiles. Now, if you remember your balance scales model, you can essentially do whatever you want to one side of the equal sign as long as you do it to the other side to keep things balanced. So do what you must do in order to solve the problem. In this case, this is going to help me solve the problem. Watch how it does that. So these 2 actually cancel each other out. These 2 cancel each other out. They're 2 zero pairs of variable tiles. And I've had to add 2 positive variable tiles to this side to make that happen. That's what I did. So I'm going to come over here and I'm going to add 2 positive variable tiles over on this side. Okay? And now I have 2 variable tiles that I can use in order to determine what one of them is equal to. So what I want to do now is isolate these positive variable tiles. In order to do that, I can remove these ones by adding a negative for each one of them. A total of 8 negatives will make 8 zero pair. And I want to do the same thing on the other side here. So I'm going to do that. 1, 2, 3, 4, 5, 6, 7, 8. I added 8 negatives over here to remove the 8 positives. So I'm going to add 8 negatives on the other side. Now remember, this is all removed, right? This is all gone. So now I'm left with my 2 positive variable tiles. And I've set it up in such a way that I've actually got a nice, neat row for each one of these variable tiles. So now we just have to match this variable tile with its respective value. So I'm going to add these 3 with those 4. And one of my x's will be matched with 7 over here. And those 7 just happen to be negative because they're red, right? And anything that's red is negative. Okay, the other x as well is matched with the other 7 remaining negative tiles on the other side of the equal sign. So there, we've used algebra tiles to solve for this problem.